love nothing more than to be proud of you.
All right, let's go. Thank you.
Sometimes there are parts of this class that make it difficult, though.
Ellis is the next Slim Shady. All right, everybody be quiet. We're going to get our work done today.
Not right now? All right, number 1. Last 4 days, Manny studied for 3 hours, 2.5 hours, 1.5, 3 hours. What is his median study time? Well, we can leave them as fractions. But when we say median, what is that talking about? The middle. So what do we have to do with our numbers? Least to greatest. So what's our smallest number here? Get out of my room, Chris.
There goes our video.
1.5, then what?
1.5, 2.5.
Just wait out there for a while.
2.5, maybe there's 3. 2 3s, there you go.
Okay? So since we have an even number of numbers here, we know our median is going to be the average of these two here. So we can say 2.5 plus 3 is 5.5. And now we could probably turn this into a decimal. So 5.5 is.
Wait, why do we write 5.5 for?
Because 2.5 plus 3. Because when we want the average of these two numbers. So we add them together, then we divide it by 2. Not quite. Check your decimal. This is 2. No, just wait there. .7. We can keep going. 2.75. There you go.
Why is it divided by 2?
Because you're finding the average. We're finding the average of two numbers, so you divide it by 2. 2.75. Or if you wanted that as a mixed number again, how can you write .75 as a fraction?
2 3/4.
That's 2 3/4. That's to turn into an improper fraction. So like this one, if we wanted it improper, we could say 2 times 4 is 8 plus 3. So this is the same number as 11/4. Okay? So, right. So all 3 of these answers represent the same thing. Okay? Okay.
Wait, where's the last number 2?
7.5. The answer was pay attention, because we wrote down like 3 different correct answers there. All right, number 2, this is probably the second most difficult one on here, so just sort of bear with me if you're not sure what's happening. Okay? Car rental charges $42 a day plus 12 cents per mile. How much will it cost to rent a car for 5 days and drive 270 miles? So, couple things we have to do here. We need to figure out the cost for the days. So if it's $42 per day for 5 days, we do 42 times 5. And that is 210.
So we do 0.12 times 2 cents.
Right. Then we find the cost for the mileage. So 12 cents times 270. This will work out to 540. Bring down the 0. 270. Okay, good. So $32.40, and that's the charge for the miles.
I don't get this question.
Okay, that's why I said just kind of go with us.
What do we do with 8%?
Well, we're going to get to that next. So we have the cost for the days, the cost for the miles. What do you think we're going to do with those two amounts? We add them together. So we say, what's 210 Correct. Line up your decimals. When don't you have to line up the decimals? When you're multiplying or dividing. Oh, not quite. $242.40. So that is the cost before tax. It's like you think like you go to H-E-B, they ring up all your groceries and they give you this total. Only after they get that total, then they figure out the tax on that.
Say it, Ellis, 240, 240. It sounds like you're saying 240.
Yeah, a little bit. So it is going to be a little bit of multiplying. If you're not sure how to multiply, we can always think of anytime we're doing percents, we can think of it as a proportion. We can think of it as tax compared to the total. What is the tax percent we know, Josh?
8.
What's the tax percent? 8. What's the total percent? 100. What do we know on the left side here? We have the total is 242. Do we have to put 0.40 or can we just put 0.4? Does 0.4 work? So we're solving for the tax. So we can cross multiply here. Doesn't work. So 193? 192? 193.92. Do you agree? That seems a little low.
What is this?
Wait, you guys are getting like a final answer here. So 190. Better? Okay. So now what do we do with that? We divide it by 100. Instead of actually working that out, we know anytime we divide by 100, all we're doing is just moving the decimal place. How many times? 2. So it's going to get bigger or smaller? Since we're dividing, it's going to get smaller, so we're going to move this decimal 2 places. Which way? To the left. So we'd have $19.39 for this round, up or down? Down. So it's just going to, if this is our final decimal place, this 2 is going to round, so it's going to stay just like that. Because that's, well, that's part of it. We're almost there. I know, I told you this was kind of involved. So our tax is $19.39. Oh, we found. So all we got to do, you take the cost before tax plus tax, and you get your final cost. So we just add it together. That's the answer. So we get 79 cents. Okay. Right. So that would be the final bill. Which part why?
Do couponers do that? Mr. Ellis. No,
we find the cost of everything you paid for. You find the tax you would pay on that. And then since tax is an additional cost, you add the two together. All right? Couponers, they could. If you ever work retail, if you ever get a job at H-E-B.
No, I'm saying like, because you know how they do all the work and they figure out the exact prices of everything?
Yeah. You could do. I don't know. Or like if you worked at a business, and let's say you had to take this trip and you knew what you were going to spend, and they're going to want you to write a check before you go, so you could actually calculate all this. Or you could call the place and make them do the work. All right, so that's it. There's our final answer right here. You ready to work now, Chris? Yes? All right. This third one, you're going to complain about this one. I'm sorry. This is the hardest question on here. Everything after this gets easier. So, bear with me for one more. And if anything, go and blame Miss Garza later. She's the one who's... All right, so she's got a paperweight shape of a square pyramid, so we can draw ourselves a little pyramid. Just draw a square with a point on top.
Are you changing the color when you change the color by itself?
What? I do that. This is the battery sign. Okay. Side length of the base measures 0.06 meters.
Is there going to be any questions this hard like that?
Harder than this? Probably not. This is sort of absurd. Could be. So that way when you take the actual test, you'll be like, oh man, this is so much easier than the stuff that Ellis made us do. He's a jerk. Why did he make us do this extra work? Since you guys are going to call me a jerk anyway, might as well give you a reason to. All right. She wants to cover each of the triangles with aluminum foil, but she does not want any on the base. How many square kilometers of foil will she need? Okay, here is the part that makes this problem really annoying, is it wants the answer in kilometers. If you think about how big a kilometer is, that's 0.6 of a mile. Okay? So if you walked all the way around the little hallways out here, you wouldn't get to 1 kilometer. Okay? You would not. And now imagine we're talking about a little paperweight, something small you put on top of your paper to keep from going away. And we want to measure that in terms of kilometers. So we know our answer is going to be very, 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 very small. Okay? So we need to think about how we can convert meters and centimeters to kilometers. So let's start with our 10 centimeters. So we talked about yesterday that 100 centimeters is equal to 1 meter, correct? Yeah. So how do we go from centimeters to meters? What do we do with our decimal point? We move it how many places? 2. Okay? So if we have 10 centimeters, we would move our decimal 2 places to the left. So 10 centimeters is going to be equal to not 0.01, but 0.10 meters. Because if we go 2 places to the left, okay? So our 10 centimeters is 0.1 meters. Not so bad. 6. But then we don't actually want it in meters, we want it in kilometers, so we got to think, how many meters make up 1 kilometer? Well, what does kilo mean?
Kilometer.
What number is that? 1,000. It's 1,000. So how many meters do you think are in 1 kilometer?
1,000.
1,000. So, yeah, kilo is just a prefix. It's Latin, means 1,000. When you think about that, if you've been watching too much CSI, okay, all right, yes, kilo is just a measure of weight. Okay, that's all right. Now we know. We all learned something. So how do we move the decimal to get from meters to kilometers? We move it how many times?
2. 3.
3. So if we have 0.1 meters. If we move that 3 places to the left, 1, 2, 3, what is that in? That'd be 0.0001 kilometers. What? I don't know. Because I'm standing underneath the speaker. Messes it up. So 10 centimeters is exactly the same as 0.0001 kilometers. So we can write that in. Stay focused, okay? Okay, really? Isaac, focus. So now we do the same thing, 0.06 meters. We would move that how many times? If we're going from meters to kilometers, we have to move it 3 times. Remember, it's always 1, 2, 3. So we go 1, 2, 3 back. So 0.06 meters is going to be the same as 0.00006. Okay? Well, that's part of it. Man. Oh, yeah. Thank you. See, I told you Jalen was listening. So, how do I do that? I just put a 0.
Come on, Ellis.
I know.
0, 0, 0.
It's because I'm trying to keep up with Isaac's conversation over here. I'm not multitasking the best today. So, could you help me out, Isaac, and not have a conversation? Thank you. All right. So that's the tricky part. Now the easy part, which is to find the actual answer to the question. So we want to know the area of all the triangles, but not the base. So is that surface area or volume of this pyramid? Surface area, because we're covering that outside. But since we don't want the base, are we looking at lateral or total surface area? Lateral. Yeah. So if you look at your formula chart, and then somebody says, oh, Ellis, that's perimeter of the base times the height. And half of that. And I say, great job. That's exactly right. And then I say, Nathan, stop talking to Jalen. Thank you. So then we fill in our numbers. So we have 1/2. How can we find the perimeter of a square? We can add them all up, or we can multiply this number by 4. So I'm going to erase all this because this makes me upset. Because you should have learned that in science. All right. So, okay, I know you're looking at this and like, oh man, this sucks. This is terrible. All this is 6 times 4, which is 24. How many decimal places are there? 5. So we count 1, 2, 3, 4, 5. So the perimeter of our base is 0.000. Okay, and then the height of it, we said was 0.0001. So we can take half of this. Well, what's half of 24? 12. So this is just going to be 0.00012. Okay? Times 0.0001. All right, we're again. So now we have one last thing of multiplying to do. Because, well, we need to know what this times this is. All right. And again, you look at it like, oh, but there's all these decimals. This is so difficult. But really, all this is 12 times 1, which is 12. How many decimal places? Total. How many are there? There are 9. So we have 1, 2. So we need 3, 4, 5, 6, 7 zeros at the end. 7. Okay? So that technically is our answer. But we got to put in scientific notation. And you should expect that anytime you get a number that looks as small as this, you should expect that you want it in.
Why is there 7 zeros if there's only 6 zeros on the team?
Okay, because we're not counting zeros, we're counting decimal places. Right? So we did this yesterday, right?
Yeah.
So we need to make a number between.
We've done it with.
Yeah, we've done it with small numbers too. So where does the decimal have to go? It's got to be 1.2. Why does it have to be 1.2? Can't be bigger than 10. So it's 1.2 times 10. How do we know what our exponent's going to be? How many times you move the decimal? Remember, don't just count the zeros. You count the number of times you move the decimal. Very good, Celeste. It is 8 places. Why is it negative? Well, backwards, yes. Why is it backwards? Because our number is a what? Is a decimal. If this was a whole number, we'd have a positive power. But since it's a decimal, it is a negative power.
Why is it
Never know.
power of negative 8?
We talked about this yesterday. Because anytime you multiply by 10, you just move the decimal one place. Yeah. So here is our. Well, anytime you do scientific notation, it's always times 10.
And then minus 8 or 7.
That's if you count 1, 2, 3, 4, 5, 6, 7. We move the decimal 8 places. It's not the number of zeros. Number of places you move the decimal. Because that's where it was. That's where we moved it to. You need to come by like after school at some point. We can go over this. All right, so like I said, that's the hardest question on here. It's all easy from here. And easy is a relative term.
Does that mean it's not easy?
Well, it's not as difficult as that. So volume of a cube, 27 square feet, or cubic feet. So we can draw ourselves a cube. This looks like 2 questions, but really, if we can answer one, we can answer the other. We want to know how long is each side here. So we think, what's special about a cube? They're all the same. And since we're talking about volume, we know that's the area of the base times the height. But since it's a rectangle, it's really just length times width times height. But what has to be true about length, width, and height?
They're all 27. They're all the same.
They all have to be the same number. And when we multiply it together, it has to give us 27. So what number times itself 3 times is 27? It's 3. So what is the length of each edge? 3. What is the area of the base?
3. 27.
The area of just one of these squares would be 3 times 3 is 9. And that's your answer.
So what?
That's it.
Why put that on the back?
So we have 9 square feet is the area of our base. 3 feet is the length of our side, and we're done. Okay. See, you do one hard problem, then the rest is like, oh, this is so easy. Okay, read it on your paper then.
A house is 7 feet wide.
What? So house is 70 feet wide, so we can call this 70. Shows the width is 2.5 and a height of 4 on the picture. So the only thing we have to be careful of is knowing what number goes with 70. So if it says 70 feet wide, what does that have to correspond to on our picture? The 2.5 or the 4? Why 2.5? Because it says width. Okay? Then the height of our picture is 4. And we want to know what is the actual height.
Okay, so can we put 2.5 over 70?
You could. There's any number of ways you could write this. You could even, if you look at the picture hard enough, the proportions written out for you. If we think of this as x over 70 and 4 over 25, would that work? Yeah. We could also do it how we usually talk about it in here. Where we say 70 over 2.5 and then x over 4. And we notice we do the same, it's the same thing just written differently. So that's what's pretty good about proportions. As long as you line it up, there's a few different ways you can write it, but they all involve you doing 4 times 70. I don't even want to repeat it. No, I don't recall any math in there. So 4 times 70 is 280. We divide that by. Okay, how do we divide decimals?
You move the decimal. Oh, you divide with this?
We never. Yes, proportions you have to divide.
Wait, 280. Why? Where did you get 280? Oh my gosh, Ryan, somebody times 4. Oh.
So we never want to divide by decimals, so what can we do to this decimal point? If we move it one place to the right, what do we have to do on the inside? One place to the right. Now we just divide like you normally would. Can't go into 2, can go into 28 once. 1 and 2. Not that I didn't believe you. I just like doing division. If you got 11.2, because your decimal places are funny, if we just think about does that answer make sense? If we think which of our sides is bigger, the width or the height? The height, which means that x should be some number bigger than 70. So if you got 11.2, you think, wait, does that make sense? No. How about 112? Yes. So 112 feet. I'm not telling you that. No. I've had that since before people called me Mr. Ellis, so no. I thought about changing it to that, but then I was like, nah, then somebody might find me. All right, Miss Herrera. That's what I said. Collect the data on shoe size and eye color. She wants to make a scatter plot. Remember we talked about scatter plots the other day? We talked about as one goes up, what happens to the other thing? Okay, so let's look at, we have shoe size and eye color. So we think as shoe size goes up, here's the tricky part. What happens to your eye color? Okay, are colors numbers? Can colors really go up or down? Oh. So can we say there's a, all right. Children. So can we say there's a positive or negative correlation here? No. What's the relationship between your shoe size and your eyes? Nothing. So we say there is no correlation. That's it. Okay.
Why is there no correlation?
I don't know if you're messing with me.
No.
I kind of think he is, but then again, I think he's there.
No, I'm not.
Okay.
I just didn't. I'm trying to finish this one if I don't get it.
All right. Let's say if we're collecting. All right. If we're collecting data here, if you looked at as people's shoe size change, how does that relate to their eye color? It doesn't. So there is.
Oh, I didn't know what correlation meant.
It means no relation.
Look, Ryan.
Yeah. It's even written.
Look, Ryan.
Get away, Cameron. I'm wondering.
All right. Yes. So that's it. They're not related, so there's no correlation. All right. 4 to go. Maybe. Hopefully we can get this one. This is newish stuff. 5 red, 10 blue. If you randomly pick a marble without replacing and then select another, what's the chance of getting 2 blue in a row? So what's the probability the first time? Okay. All right, stop.
It's 2 out of 15.
Remember, it's always favorable over possible. Favorable means what you want. So if we want to pick a blue marble out, how many favorable outcomes are there? 10. There are 10. 10 out of how many possible outcomes? 15. Okay? You got to remember, because I still hear people saying 2 out of 15 because we want to pick 2 of them, right? Yeah. Think of them as separate events. Think of picking one out. What is the chance of picking one blue marble? It's 10 out of 15. Okay? After we pick that one out, what is left in the jar? There's 9 blue and how many total? 14 total. So what is probability of picking blue the second time? 9 out of 14. So what do we do with these two numbers? Not cross multiply, but multiply straight across.
Why is it only one number down on each?
Yes.
What?
Make sure to simplify. I would simplify first. Can you simplify 10/15ths? What is 10/15ths? Is how about 9/14ths? No. Can you simplify 18 over 42? Yes. So simplify that. That's your answer. You can keep simplifying that. You too? Because the battery's dying. I can't. I'm working. That one you have to hold up. Yeah, but it doesn't work as well. Simplify that. Simplify it more. There you go. Yes, of course you can. All right, just a reminder, don't forget, if you don't want to simplify at the very end, you can also simplify diagonally.
Why are you timing 10 over 5, 15, and 9 over 14?
You got to come before or after school. I can't re-explain everything. Like, we literally, just explain that. Or you know what you can do? Go home tonight, youtube.com, /users/the real Mr. Ellis and watch this like over and over and over again.
No, I don't want to watch it.
Okay, if you don't want to watch and learn, why should I explain it to you a second time?
I want to watch it.
So let's say 3/7. Yes. Don't forget, you could have always simplified 2 and 14. You could divide those both by 2 and get 1 and 7. You could simplify 9 and 3 and get 3 and 1. And then 1 times 3 is 3, 1 times 7 is 7. So 2 ways to simplify.
Can you simplify 9 over 14?
No. Okay? What? I don't know, I saw people not really working. Sort of annoying. And we've got other people just sort of playing around. Alright, list of sources, whatever. Convert these fractions, list them from least to greatest. Since they're already all percents, can we put them in order before we change them? Yeah. So what is the smallest number up there? 7%. And 12. Oh yeah, 20 is up there. 27. Okay. It wants these written as fractions, though. How can we write any percent as a fraction? You put it over 100. So we have 7 over 100. How about 12%? Is that going to be our final answer? Why not? Because we always simplify. Which of these can't we simplify? This one's good. 7 over 100 is good. And what else? 27. Right? So simplify those other two. If they're both even, you can always simplify.
If they're both odd, you can do it sometimes.
What? Sometimes you can, but not always. You got to simplify first. The next question. You're simplifying what's up there? Just the ones that don't have check marks next to them. Thank you for paying attention. Now right now we have people out.
Is that number 6?
Yes.
Number 9. You're almost done. Hey, John, here. Can I go now?
Yes. All right, so 12 over 100 is the same as what?
3 over 25. 3 over 25. 325. I told you, you don't even know what I'm talking.
Okay. How about 20 over 100? 1/5. Is 1/5. Okay. Why do we put them in order before we simplify? Can we compare fractions that have different denominators? No. What if they have the same denominator? What do we notice about all of our numerators? Are they in order? Yes. So the only time you compare fractions is if they all have the exact same denominator.
How is 20 1/5? It's not 1/5. It's not.
Yes, it is.
It's 5.5. How do you get 1?
Divide them both by 20.
Whatever.
5 over 25, you can divide them both by 5.
All by 5.
All right. Number 9. Okay. Number 9, we have 1 point at 1, negative 3. If we dilate that by a scale factor of 5, remember we think of points being in one dimension, so what do we do with those numbers? Not add. If we talk about scale factor, we always use what operation? Multiply. So what are we going to do with our x and y coordinates? So we're going to say times 5 times 5. So 1 times 5. Good job. Negative 3 times 5 is negative 15. That's your answer. Remember, a positive times a negative will always be negative. Really, really. Not right now.
I didn't have no question to ask on this one.
Hopefully. We only have one question.
Let's go, Alice. Click it. No.
We got.
Click it. Make it perfect.
It's not the question. I mean, you can go on the tax test and be like, well, I showed my work here that 2 plus 2 equals 4. And yet I got the question wrong. I don't understand. Well, if you don't actually answer the question being asked, it doesn't matter how correct you are. Okay.
We're making record time.
So, 4th and 5th terms. So that means we want to replace what with 4 and 5? Remember, anytime we talk about terms and sequence, all the terms are represented by what letter? N. Which means to find the 4th term, we'd have to replace n with a 4. So we have negative n, so that'd be negative 4 divided by 2 minus 3 times 4. So we can do the dividing here. Negative 4 divided by 2. Negative 2. Minus 12 is negative 14. So our 4th term okay, then we need the 5th term. So everything's going to stay the same except for these 4s, which will now be 5s. So we have negative 5 minus 3 times 5. So 5 divided by 2 is negative 2.5 or negative 2.5 minus 15. There you go. If I owe you $2.50 and Jordan owes you $15, how much do we owe you total?
17.
Well, don't forget your change.
50 cents.
It'd be $17.50. And there are. Yes, we did. Okay, don't. All right, so shout outs to the people who are working the whole time. So Kayla and Chris A, Natalie and Haley and Jared most of the time, and Alyssa T, and Cameron and Luke and probably Carl, Jordan, almost Tuna, not really Josh, Becca and Blake, Jalen most of the time. Almost Nathan when he wasn't sleeping. Ayana,
I didn't ever question him.
Celeste some of the time, Brianna all the time, Johnny all the time, and Ryan for asking 80 questions that should have been answered months ago.
Hey, wait. I have a question on this. Who's going to watch a 45-minute